In this video, we're going to start talking about probability and kind of the definition and talk a little bit about simulation. So this first bit is just a little bit of kind of getting you used to thinking about probability. I flip a coin 6 times. Which of the following outcomes is more probable? So you can see getting this first thing right here represents, that you got heads, heads, then tails, then heads, then tails, then heads. And this is that you got 3 heads in a row followed by 3 tails. Well, the order here is specified. In each one of these, you got 3 heads and 3 tails, but just in different orders. So the answer here is that neither is more probable. Okay, and the reason is because this order was specified. If you think about, what's the probability in each thing? Well, 1/2, 1/2, 1/2 for each thing. Same over here. So the probability of getting 3 heads, 3 tails is the same regardless of the order. Now, if you think about, if I said to you, what's the probability of getting all heads, 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 compared to the probability of this specific order, again, those things are the same. However, if I say what's the probability of getting 6 heads versus what's the probability of getting 3 heads, 3 tails in any order, it is more likely to get 3 heads, 3 tails if the order doesn't matter. Okay, so that's something we're going to talk about as time goes on. But in this case, because the order is specified, they each have the same probability. All right, match a probability to the statement. This outcome is impossible. It will never occur. If something is impossible and will never occur, its probability is 0. This outcome is certain. It will always occur. Well, then it has a probability of 1. This outcome is very unlikely, but it will occur once in a while in a long sequence of trials. This is a probability of 0.01. The outcome will occur more often than not. This is a probability of 0.6. So, what is probability? Well, probability is simply a number between 0 and 1 that describes the proportion of times that an outcome will occur in a long series of repetitions. So the reason we say that the probability of getting heads on a coin is 0.5 is because if you did a large number of trials of flipping a coin, then the proportion of heads you get will be about 0.5. Okay. The reason we say that you have a 1/6 probability of getting a 6 when you roll a die is if you roll the dice thousands of times, then the proportion of times you get a 6 will approach 1/6. So it's really the idea of if you want to relate it to calculus, kind of a limit, that is what we should be approaching as we do more and more trials. So I wanted to just talk about doing that once. So Joe Mauer for the Minnesota Twins, lifetime .308 hitter. This means that that the proportion of times he gets a hit is 0.308. So there are a couple of ways we could do a simulation here. We could certainly do it with with slips of paper and put in certain slips, but we could use the RAND function on the calculator. But I'm going to stick with RAND int. Okay, so I'm going to do a RAND int. And I'm gonna stick with whole numbers. So I'm gonna do 1 to 1,000. Okay? And if that number pops up between 0 and 308, I'm gonna say that that's a hit. And if it's 309 or above, I'm gonna say that it's not a hit. Okay? Now, I did this in my calculator, and I actually just generated quite a few of them. You can see here, I have 25 spots. So I did RAND int 1, 1,000, and then I did 25. So you can see right here, this is not a hit, and then a hit. And then, of course, this looks like 500 and something, so it's not a hit. So here's what I'm going to do. I'm going to start this, and then I'll pause. Think about it like his season started just now, right? When I started this simulation, his season began. So the first at bat, he didn't get a hit. So he's 0 for 1. He has 0 hits and 1 at bat. So his batting average on that first at-bat is 0. Okay? Now the second at-bat is also not a hit. Right? 909. So now he's 0 for 2. But the third is a hit. So now he's 1 for 3, or 0.3 repeating. So I'm going to just kind of guess that that's up here. Okay? And the next one, as I said, is 500 and something. So now, once again, it's not a hit. So we're down to 1 for 4, or 0.25, which is probably right in here. I'm going to build this a little bit more. I'm going to pause and build so you don't have to see me do the whole thing. And then we'll regroup and see what's happened. So I've completed the simulation for 25 at-bats. So what you can see here, picking up where I left off, is that Joe got in kind of a roll, and the batting average was driven up towards 400. And then you can see it dip back down, and that's kind of what happens, right? But it really does center in on that 308, which is probably somewhere. Let's use a different color. Somewhere in here. And that's kind of what that bounces between. So what I wanted you to see here is that there's not really such a thing as the hot hand, or someone's due for a hit. That when you do a simulation, what probability says is, in the long run, this is the chance, or the proportion of times that this person will, in this case, get a hit. Okay, we've set this simulation up that 0.308 is the proportion of times a hit will happen. So yeah, you may start off with some times where, he didn't get a hit, and then he gets a bunch of hits and it goes up, and then it just kind of goes down. If you want to use the language of calculus, it's really a limit. What happens in the long term? So sometimes we get in trouble in probability of looking at things through too small of a lens and not thinking globally. You got to think in the long term. If we ran a long-term simulation, what would that tendency be? And of course with Mauer, you can see it is really tending towards that 308 line.